Okay, class. Let's look at the first example for Z transform. Okay. Okay. As you know, Z transform is can be represented by uh, x z equals to summation of x and z negative n. Okay, so and then we also know that from Z transform, we can determine the ROC, where the region of convergence um, that to and to make sure that the Z transform is exists, this summation x n z negative n needs to be converged, where maksud dia needs to be converged, meaning that exact it must the summation of s n z to negative n ni dia bukan infinity, it must have some magnitude. Okay, meaning that it is not an infinity, and it must less than a certain value. Let's say the value is alpha. Okay. Ataupun dengan kata lain, if x z or x e j omega, this is for the case of Fourier transform, has magnitude, nilai magnitude value, which is ataupun dalam kurungan exact bukan infinity, then kita boleh katakan that exact is exists. Z transform is exists. Z transform is existed. To make Z transform exist, the summation need to be converged. How to make it converge? This summation must have value less than 1. Maksudnya dia kena tertumpu. Tertumpu. Converge lah. Dia tak boleh mencapah. Kalau mencapah, nanti dia makin besar. Meaning that the summation will reach infinite. So, okay, let's look at our example. A discrete time signal is given as xn. Okay, xn equals to a and un. Okay, this is our discrete time signal. Determine the exact, which is the Z transform, and the region of convergence. Okay, so this is the formula. The Z transform representation is known as exact equals to x n z to the negative n. So this is our xn, a n u n. Okay, apa maksud un ni? Un ni bermakna our n is from 0 to infinite. So kita ada ni lah, our new summation is started from 0. Kalau yang ini n is equals to negative infinite to infinite, this is the general formula for Z transform. And then this is the new one where we we acknowledge that un is n equals to 0 to infinite, so that our xn now will become only a n. So a n, where n is from 0 to infinite, z negative n. So if this a n z to negative n can be put it this way, which is A Z negative 1 in bracket n. So n is from 0 to infinite. So because un is 1 kan. Okay. Un is 1. Okay. Next. Okay. This summation, kalau kita kembangkan ni, dia sebenarnya adalah A Z negative 1 0 plus A Z negative 1 plus A Z negative 1 power of 2 plus ... until infinite lah. So this is an open form solution. And using geometrical series equation, okay, we can find the exact equation where, okay, tengok sini ya. Ni, summation of alpha k for k from n1 to n2 is equals to alpha n1 minus alpha 2 plus 1 over 1 minus alpha. Okay, maksudnya sekarang for our case, we have kita punya ni a n z negatif n kan? A z negatif 1 n. Okay, n from 0 to infinite, a z negatif 1 ni adalah a lah, adalah alpha. Alpha ni adalah ni. A z negatif 1, while our k tu adalah n. Ni n ni adalah k lah kalau dalam geometrical series equation ni. So our n from 0 to infinite, a z negative 1 n equals to a z. So a z minus 1 from 0 kan? n1, k is from n1 to n2. So our n1 is 0. 0 minus this one, a z negative 1. Okay. Okay, sorry. So a z negative 1, n2, this is n2 plus 1, n2 dekat sini. So infinite plus 1 is also infinite lah. So this one is infinite. Over 1 minus a z negative 1, because our alpha is a z. Our alpha is a z negative 1. Okay. So 1 minus alpha a z negative 1. So this is our closed form solution. So we'll find that a z equals to a z negative 1 minus a z negative 1 infinite over 1 minus a z negative 1. So as we know that this one is 0. This one is equal to 0. This one is equals to 1. Because a the power of 0 is 1. A the power of infinite is 0. Z the power of infinite is 0. Okay. While we want to make sure that x exists, our summation ni, our open form solution ni need to be converged. And how to make it converge? Okay, to make it converge, we need to assign the value of z ni. Okay, to make it converge, it must be less than 1. So a over z is less than 1. So we'll found that z must be, our z, the value of z must be greater than a. Then kita akan dapat dia tertumpu. So how to make it converge? Az, the power of negative 1, must be smaller than 1. We need to set that. Okay. So then, okay, now we know that az is equals to 1 over 1 minus az negative 1. Okay. And Z is greater than A. So this is ni lah for convergence ya. For converge, Z must be set bigger than A. So in our ROC, ROC ni we need to draw the poles and zero. So how to find the poles? Poles is located, ni pole, A is our poles. Poles is located at the denominator. So our poles is dekat A lah. A. Let's say A tu dekat sini. A. Okay. ROC, Z must greater than A. So our ROC is outward. Outward of A. Yang dekat luar sini. Semua ni adalah the ROC of our Z transform. Okay, now look at the example number 2. Okay, Z transform. Exact Xn is equals to 3 over 4. Yeah. Okay. Let's say this is our discrete time signal. Xn equals to 3 over 4 the power of n, un. Okay, un ni meaning that our n is from 0 to infinite. So, okay, kalau kita masukkan dekat dalam formula ni, xn z negative n kan. This is z transform. Z transform is xz equals to xn z to the negative n. So, xz equals to n from negative infinite to infinite, 3 over 4, the power of n, un z negative n. So, un is n from 0 to infinite. So, you will find that xz equals to the summation from n equals to 0 to infinite, 3 over 4, the power of n, z negative n. So, this is our Z transform lah. Z transform, open form solution. Okay, so kalau open form solution, dia akan jadi, this is equals to 3. So, I don't know why it happened. 3 over 4. 3 over 4, Z negative. Z negative 1, 0. Plus 3 over 4, Z negative 1. Plus 3 over 4, Z negative 2. Plus until infinite ya. Until Z negative infinite. So this is open form solution. And using geometrical series equation, this one, geometrical series equation Oh, sorry. Series equation n from 0 ak equals to a 0 minus a infinite over 1 minus a. So our a is equals to ni lah. This is our where a equals to 3 over 4 z negative 1. Then, using geometrical series, we can find the exact equation where z equals to 3 over 4 z negative 1, 0 minus 3 over 4 z negative 1 infinite over 1 minus 3 over 4 z negative 1. So, this is equals to, this one is 1, this one is 0, and the denominator is 1 minus 3 over 4 z to the negative 1. Okay, then you will get exact here. Exact equals to 1 minus 1 over 1 minus 3 over 4 z to the negative 1. Okay, and then to make it converge, as you know, 3 over 4 z negative 1 must be less than 1. Okay, then you will find that z must be greater than 3 over 4. This is the ROC. The ROC Z must be greater than or bigger than 3 over 4. So, where is the 3 over 4 ni is the poles lah. Denominator kan. So, this is our poles lah. Z must be greater than 3 over 4. So, let's say the 3 over 4 is here. 3 over 4. Then, this is the unit circle This is the unit circle. Unit circle ni dekat 1. Value dia is 1. So, as shaded area is included in the unit circle. Okay, kalau kita tengok dekat sini, shaded area ni adalah ROC All the shaded area is ROC. Then since unit circle is included, this signal has its Fourier transform. Therefore, this signal is stable. So, kalau kita nak tahu signal tu stable ataupun tidak, you must make sure that the unit circle is included in the ROC. Okay? The unit circle must be included in the ROC. Okay. Now, let's look at example number 3. Okay. For example number 3, a discrete time signal is given as xn equals to 1.65 n un. Okay, determine the exact and the ROC. Okay, this is our discrete time signal. Okay, 1.65 power of n. And as you know, our n is from 0 to infinite. This is to, because we assign un, un is equals to 1 from 0 to infinite. So this is our Sn, 1.65 n, z negative n. So then it will become like this, 1.65 z negative 1 n. Okay. And to make it converge, 1.65 z negative n must less than 1. So to make it converge, you need this, the summation need to be converged by put it less than 1. So then we get that our ROC Z must be greater than 1.65. So our ROC must be greater than 1.65. Okay. Using geometrical series equation, we can find the exact equation as 1.65 z negative 1 0 minus 1.65 z negative 1 infinite over 1.65 z to the negative 1, and it is equals to 1 minus 0 over 1 minus 1.65 z negative 1. So this is the final answer for the Z transform. This is our Z transform, and our ROC is Z greater than 1.65. So, look at here. This is our ROC. Our poles is at 1.65 kat sini. This is 1.65, and this is our unit circle. And this is our unit circle. Unit circle at 1. The value is at 1. Okay. 1, positive 1, negative 1. As shaded area is excluded. Kalau kita tengok sini, our shaded area is not included, is not include unit circle. Unit circle is excluded from the shaded area. The ROC is outside the unit circle. This signal does not has Fourier transform. Therefore, this signal is not stable. Okay, because to make it stable, it must include ROC must be in the shaded, the unit circle must be in the shaded area. But now, the unit circle is not included in the shaded area, but it is inside. So, it is not stable. Okay. Example 4. A discrete time signal is given as xn equals to negative a n u negative n minus 1. Okay. For this example, okay. Tengok kat sini This discrete time signal is equals to negative a n But now the step function is u negative n minus 1. Okay, kalau kita draw, if we draw if we sketch the signal, macam tu. Okay, let's say A equals to 2. So, if you draw, it will look like this, Xn, Xn, and negatif kan? Negatif An, negatif 2. Oh, sorry. Skip, skip. Okay, okay. So, Xn equals to Allah. Okay. Negative 2 and U negative n minus 1. So, U negative n minus 1 ni bermakna n is from negative infinite to negative 1. Okay, itu maksud dia. U negative n minus 1. Because it is shifted at the left hand side, shifted at the left hand side. So, meaning that our okay, so dia ini amplitude dia dekat bahagian negatif lah. So dia macam ni. Dia macam ni. Okay. Dia macam tu. Makin lama makin besar lah value dia. Makin besar ke bawah. Macam tu So dia makin ke arah negatif dia makin kecil. Kecil macam tu. So dekat kosong ni nilai dia 1. Negatif 1. Okay. Ni kita punya kosong. Ini kosong kita. Okay. So in here, back to the to our question. So just let put A is A, not negative 2 It's only A. So exact is equals to negative from okay, kalau tengok dekat sini, from negative infinite to positive infinite, negative an, u negative n minus 1, z to the negative n, this one. So we put it here. So it is equals from negative infinite to negative 1 lah. Kan, negative infinite to negative 1. Put it ni ya. Yang ini kita letak dekat summation sini. So kita dapat n daripada negative infinity kepada negative 1, and then our magnitude is negative kan, negative an. So negative tu letak dekat luar. So the only in bracket is az negative 1 the power of n. So and then how to we can simply change the summation ni to be positive by changing the magnitude here. Okay, free negative ni jadi positif, change to the jadi positif, positif kat sini jadi negatif. Okay, because it is summation, so we can simply change lah. Okay, and then so finally our put the negative ni, negative n ni, put it inside, and then our n ni dah jadi macam ni. So now our magnitude is a negative 1z. Our the value is a negative 1z, and it is to the power of n. So similar, to make it converge, a negative 1z must be less than 1. Then we notice that our ROC now become z less than a. This is our ROC. Okay, z less than a. This is to ensure that z exists in the summation. The summation need to be converged. Then to make it converge, the summation must be less than 1. And then we will find that z is less than a. Okay. By using geometrical series equation, so it will become like this. Ni. Kan, sebab dia daripada 1 ke infinite. So kat sini 1, dekat sini infinite, dekat sini is similar lah, 1 minus a negative 1z. Okay, so finally kita akan dapat z equals to 1 over 1 minus az negative 1. Okay, this is same same like in example 1, except now the ROC is less than a. So kita akan dapat dekat sini ROC kita ni a, the poles kan, our poles dekat a, but now our ROC is inward. Inward ROC. So macam mana nak tahu insert ROC inward ataupun outward? Senang je. Kalau kita punya discrete time signal tu UN, so kita akan dapat outward ROC. Kalau kita punya discrete time signal kita U negative n minus 1, then kita akan dapat, maksudnya dekat sini ni n tu adalah daripada negative 1. Daripada negative infinite to negative 1. Kalau UN pula, kalau UN maksudnya kita punya discrete time signal kita exists for n from 0 to infinite. So untuk case yang ini, dia adalah inward lah. So kalau kita ada U negative n minus 1, then it will be inward ROC. Okay, that's all. Thank you.